I'm not sure Elena could hear us either. For a second, too.
Elena?
Okay.
Elena? Can't see
To the
her.
quiz.
Oh, there we go.
Sorry.
Hi. That's okay. So what did you guys get for number 1?
I put central limit theorem.
Okay.
Yeah, that's what I put.
That's what I put too.
Cool. Then number 2, you guys get law of large numbers.
Yep.
Yeah.
Cool. Awesome. And then number 3, I got just number 2.
That's what I did too.
Okay. Cool beans. And then number 4, what did you guys get?
I put the
Selected
mean,
random choosing.
I put the mean of the IQ test score in the U.S. as the parameter, and then the other one is the statistic.
Right.
And why would it be that? Why would mean be the parameter and then the statistic is the randomness?
The other mean. Let me pull it up. So, because your 20 selected students is like the sample from the population, and so they're the 20 students from the U.S. So
okay, that makes sense.
So your sample would be your statistical parameters, like the U.S. It's like the population.
Okay, that makes sense. Yeah, that makes sense. And then what did you get for number 5?
I put stratified sample.
Yeah, that's what I got too.
What did you do? What was that?
Stratified. I did that too.
Okay.
And then number 6, I also got stratified. I don't know if that's right. But
I put systemic. I don't know.
I put cluster.
The cluster?
I put cluster.
Cluster too. Oh.
Here,
Okay.
let me read it real quick. Yeah, so it's because clusters, you use everybody in the sample group. So their samples that they chose from were the teachers, and then they tested all the students in that class.
Okay.
That's why I put cluster.
Yeah, that makes sense.
Where?
So it's like your district is your population, your teachers are your different blocks or groups, and then the students are the samples in each group, and you're using all of them in each sample.
Okay, yeah, that makes sense. And then number 7, I got simple random sample.
That's what
And then number 8, I got stratified again.
That's what I
Yeah, that's me too.
Cool. And then and then number 9, I got the mean was $4.77.
Yes.
Yeah.
And then the standard deviation, $1.91.
Yeah.
Yes.
Okay.
Hmm.
And then the number 5 cents, $2.86, $4.77, $58, and 59.
Yes.
I got something different, I think.
What did you get?
I got the .84 as the minimum. And then 3.39, 5.15, 5.71, and 10.45. So
Be
maybe
right
that was
back
the
again.
program I was using.
What did you get for the standard deviation?
1.91.
Okay. So to find the minimum, wouldn't we just divide it? I mean, not divide it. Wouldn't we just subtract it by 1.91 twice?
I was using the what is that? That VMware stuff,
Okay.
and I just put it in the statistics thing, so it gave me my mean and standard deviation, and then it also had your minimums and your quartiles and stuff on there too.
Okay. But if we were to do it manually, wouldn't we just do it like? Wouldn't we just subtract? Um, wouldn't we just subtract the what do you call it? The standard deviation to a different one? Does that make any sense?
Yeah, I think so, but I think that gets you like your extreme, you know. I don't know if that's actually the minimum or not. Because I know when we were talking about those, they had us doing it once with the SBSS, and they had it some other times without, I think. Because they never had us actually calculate it, I don't think.
Okay. Well, I trust the system that you like, the program that you have. So
Okay, if you want to use it.
yeah.
Yeah, because it put the minimum and the quartiles on there.
Okay. All right. And then number 10, all we had to do was make a histogram of it. So
Yeah, I used to use the program to make a histogram too.
that's what I did too. And then number 11, how I didn't really know how to do 11 and 12. So
So what I did, I just took the median from the first chart, which is the representative temperatures. The mean,
Yeah.
excuse me. Is that where you started with that? And then plug that into the next chart for the seal's body temperature. So the first seal, body or whatever, and take the mean and subtract that from each of those representative temperatures. Is that what we're supposed to do? That's how I did it.
Yeah, when I did the graph, I did the mean of the body temperature. Yeah, the representative temperatures, and then I just kind of followed because you know how it says like x minus the x with the bar, which is the mean, and I just followed that.
Okay, so that's all. That's what the X with the little line above it means is mean.
Yes.
Oh, okay. Well, then that makes a lot of sense. Well, then that's easy.
Yeah. Yeah, I think later with the sample means, I think they use that as your value. So
yeah.
Yeah,
it gets confusing.
Right. So you take everything in first column, find out the mean, and then subtract it from. They'll plug it in there.
And then I squared each of them.
Yeah, and do you square them all and then add them up, or you add them all up and then square the sum? I can't remember.
I think your variance or whatever is I think it's the sum of all squared deviations.
So
So I
you're
squared them all first.
Square them all first. Okay, I did that too. And then I did the
But
sum.
I'll look at my notes real quick. I've got to flip back to them. But I think that's what it was. Yeah, that's what it looks like on here. It's just the sum of the squared.
So you square all them individually, and then you, with that sum, all those totals, you add it up, and then
Square root it to get your deviation.
yeah, and then square root your sum, right?
Yeah. Yeah, sum of squared deviations.
Okay.
So can I go over the numbers with you, Victoria, to see I'm on track in your little chart?
Yeah, sure.
Okay. So on the square deviations, did the first one, did you get negative 0.16? And then when you squared it, did you get 0.0256?
I got 0.027225.
Okay.
Let me check that one though, because I was using my big calculator and put it as a list, and then just I put it as a list and then subtracted the mean from the list. Did it that way. So. Yeah, I still got that.
So you got zero. What was it again that you got?
0.027225.
What was that for? Number 11?
Yes. She's telling me what she got for her variance, which is the second column, x minus the mean, and then squared. I got something different.
11 is the 11. I got negative 0.165.
Okay, that's what I got.
Yeah, that's what I got too, but I think maybe. Okay.
And then what did you get for 12?
For 12, I got 0.680625.
Okay, that's what I got. Okay.
Okay.
Good.
People are trying to contact me. I can't talk. I'm in another group. It's another group trying to contact me. I'm like, I can't.
Are you meeting at the same time for another group?
No. But they're all of a sudden they're texting me all right now. We have a video presentation due.
What class are you taking?
Microbiology.
Oh, you're taking that online?
Yeah.
That's probably really busy, huh?
It can be, yeah. My teacher's
I'm
weird.
taking that lab on campus right now.
Oh, really?
Mm-hmm.
I think it's actually not required for my major, but I needed the credits, and I was like, but I'm a microbiology major. It makes sense to take the microbiology class.
Seriously.
So,
what? That doesn't make sense.
I know, right? No, I have to take a bunch of cellular whatever classes instead. But but I had to send them a video, and apparently it's not letting them access the video, which is a problem. Anyway, can do this stuff.
Oh.
They can wait. So.
So to find all the square deviations and then find out what the quantity of all of those is equal to?
For which number?
For number 13?
Did you already answer number 12? Did I miss that?
Yeah, we got 0.681.
Oh, I thought you were supposed to answer what it represents, not an actual value, number, I mean, but it does say value, right?
Well,
I thought it's the variance. That's what I answered, variance. Oh, so
Yeah.
so what? It's the variance. I thought that was the answer. Okay.
13, yeah. I think C is the answer.
okay.
And I think 14 is where
Yeah,
we.
I put that too.
Okay. So then 14, to find the standard deviation, we can just do that in the SPSS applet, right?
I calculated it because if you can find this, the standard deviation is just the square root of the squared ones.
Of
Oh,
the variance, right?
Yeah, so if you just add up all the ones in that last column
mm-hmm.
and then square root that.
Oh, that's how you get the standard deviation?
Mm-hmm.
Yeah, I forgot that too. I'm glad we're reviewing all this. Yes.
I will do that really quick then.
Yeah. Let's see if I can do that too. Oh, my numbers are wrong though. There.
So you said add all of those up and then square root it?
Uh-huh.
Okay, I don't know if I did it wrong. What did you get for the standard deviation?
I got 1.239.
Okay, yeah, so I did not do that. So can you tell me what you did again? So you said you added up all of the square deviations.
Uh-huh.
You added all of them up and then you just square rooted it?
Yeah. What did you get when you added them all up?
When I added them all up, I got 819.715.
That's not what I got.
Okay, let me try it. Wait a second. I missed a decimal place.
I was like, oh, this
Yeah,
large.
because okay, there we go. So that time I added them up and I got 1.534. So what did you say you got for the standard deviation?
I got 1.239.
Perfect, me too. Cool.
Okay.
I did it. Hmm?
Okay. I just sent off that text. That distracted me. I was supposed to have that assignment too. We were gonna turn it in like today, so.
Do you need to go check that out and come back?
No, it's okay. I got it.
Mhm.
I sent them a message, and then my email also sent me a thing to allow them. So hopefully that works.
Per student and an additional $55 per section.
Okay. Sorry. Like my brain just went in like two different directions for a second. Now I gotta get back.
Fine. We're not going at light speed or anything here, so it's okay.
Okay.
I'm still trying to get your number that you have.
Did you get when you squared the negative 0.165? Did you get the 0.0272?
Yeah.
Okay.
Maybe I'm going off too many. So, well, we can move on. That's fine. So, you add it up to get the standard, the standard deviation, and then you square root it, or this, yeah, okay.
Yeah. So you add it up, and that gives you your variance. And your
Mhm.
variance, by definition, is the deviation squared.
Right.
So you square root that.
Okay. Well, we gotta move on here. Let's see. Everyone ready to move on?
Yep.
Yeah.
15. Under certain conditions, the standard deviation can be negative. False. Never be negative.
But okay, number 16.
I seriously need help on box plots. I do not understand them. I mean, I just don't understand, but we're almost there.
Oh, is it later?
Yeah.
Okay.
We're on 16 now.
So then just the question is, which location resulted in most consistent temperature measurements from one seal to another? Justify your answer. I said X girl, just because the standard deviation is the smallest.
I agree
Yeah,
with
that's what I
that.
said too.
That's what I put too. And
Yeah.
that's my explanation too, because the standard deviation is the smallest.
Yeah, because it just means the values are are closer to the mean, which it would be that they're closer to one another.
And then number 17, it just says explain what standard deviation is. We kind of all know what that is. And explain what it represents.
I just put that it's how far away from your average value.
Yeah, I put how far it's shifted from the mean.
Yeah. Cool. And then for number 18, is give the 5-number summary of this data. I got 2, 4, 6, 8, and 12.
That's what I got too. Did you still need
So
help though?
Yeah, okay, so the 5-number summary, the first one is the sample amount. And 2, how did you get 2? It's the sample amount.
The first one, your 5-number summary is just the minimum. The first quartile, the median, the
Oh,
third quartile, and the maximum.
oh, okay.
Yeah.
The minimum is 2. Okay, I got that. The maximum I put 12. So
Yeah.
is that right?
Mhm.
No? Okay. And then the mean is 6.
Yeah.
And the standard deviation is 6.
We don't have to put the standard deviation
Oh,
in the
okay.
5-number summary.
The 5-number summary is the sample size, the minimum, maximum, and mean. That's 4. I missed 1.
Yeah. The 5-number summary is the minimum, the median, and the max, and then the first quartile, so like the 25 percentile,
Right.
and the third
Right.
quartile, so the like 75 percentile, which is always what's in the boxes.
Okay. So minimum, median, first quartile, second quartile,
Your second
and the max
quartile and your median are the same.
and okay, and is that in that actual rectangular box? Does that represent that, or is that the actual dark line? Is that the
The dark line's your median,
right? Right.
and then your first quartile is the edge of the box on the left.
The whisker. Okay.
Yeah, so the 4.
So they call it the whisker. Okay.
Yeah. And then your third quartile is the one on the right. So at 8.
Oh, okay. So let me write that in. Third quartile.
Mm,
It's always going to be the end of that rectangle, okay, or the
Yeah.
box. Okay. So the first quartile is at the 2, you said?
Your minimum is at 2.
Okay, minimum is at 2. First quartile is at the 4.
Mm-hmm.
Median. Okay. And what represents the last whisker at 12? The max?
That's the maximum.
Maximum, okay. All right. I don't know why it's hard for me to understand that, but it is.
That's it.
Okay.
Yeah, so you're just kind of saying, like, here's your median, and that's just the middle. And so here's 25% of the data on one side, and here's up to 25% of the data on the other side. And so this is where, like, half of your data is going to occur, or most of it is just in this box.
So it's going to be symmetric in a way because it's a standard, I mean, it's a normal distributed, like a bell curve, but it's in a box, right? Same kind of thing.
Yeah.
So it's going to be. Okay.
Yeah, unless like the graph is really skewed or something, and then your third quartile is, or one of your quartiles might be drug out more or something because the maximum or something is more values are on that side.
Okay. All right. So are we ready to answer 19? What percentage of the data lies between 4 and 8 hours?
I put 50%.
Yeah. Now that you explained it better to me, I would say 50%.
Yeah.
Well, then number 20 says estimate the mean of the measured nitrate concentration in Rexburg drinking water. So isn't there I'm just looking for, oh, there we go, summary. So wouldn't there be an equation for that? Maybe not.
I didn't use an equation.
Okay, so how did you?
Well, I put, since the mean minus 2 standard deviations is the 1.59,
Mm-hmm.
And
Okay.
the mean plus 2 standard deviations is the 2.52. I just subtracted those two.
Ah,
That's
So
what
it got the difference between, and then divided by 2, so it'd get what was kind of in the middle.
okay.
And then I just used, I just did the 1.59 plus what I got for that value.
Oh, okay.
And it was the same as if I did the 2.52 minus that value. So it'd be what was right between them.
Okay.
I knew there was something up with that information. I'm like, okay, they're giving this information, but how do I use it? Okay.
Yeah, it's like it's just tons of information, so it's like,
They're
what
telling me
do I
something, but I
actually
don't
mean?
know. Okay. So 2.52 minus 1.59, that's 0.93, and then you divided that by 2, you said?
Yeah, because that's just your difference between the two. So then you divide it by 2, and that gives you like the distance between that standard deviation and the mean.
Okay.
So then you use one of those. And I used the 1.59 and then added that number. So that was the distance.
The mean, right?
That gives you
The calculated mean. Excuse me.
so when I subtracted the 2.52 minus 1.59, I got 0.93. And then I divided that by 2, and I got 0.465.
That's what I got. Okay.
And then I got 2.055.
I got 1.125. Is that what you said?
I got 2.055.
You subtracted 1.59 from 0.465?
No,
Oh.
1.59 plus 0.456.
Oh, okay.
Or 65. What did I write down here? Maybe I did it wrong. 2. Okay. Got it. I just have kind of dyslexic moment, I guess.
So Victoria,
Uh-huh.
what did you get for 20, 21, 22, and 23?
20, I got 2.055.
Right.
21, I got 0.2325.
How did you get that?
I just used since we know the 0.465
Mm-hmm.
is between the distance between the mean and that standard deviation, or
So
that
that's
other value.
is that the variance then?
That, well, it equals 2 standard deviations.
Okay.
That's how I used it, because that would be your distance there. And then I just divided it by 2. So it's kind of like you have your whole, and then you divide it into half to get where your mean is, and then you divide it into another fourth to get your
So 21, you divided 0.465 by 2?
Mm-hmm.
And you did that because the 0.465 was 2 standard deviations away?
Yeah. Because that was the distance between the two.
Okay.
I just kind of thought of it as it wants, all the values between this number and this number, and then you have to find what the middle number is. So you just find the distance between and divide it in half. And that gives you your distance to move. And then you divide that in half to get your kind of your quarter. Or what was it asking? It asked for
Standard deviation.
yeah.
Okay. And then 22, did you get 1.59 and 2.52?
I got 1.82 and 2.28 or 29.
Okay. So, is it because, so we go from the mean, which is 2.055, right?
Yeah.
Okay.
And
Plus
then
0.2325.
2.5. Yeah. And then subtract that on the other one.
Okay.
So you take 20 and subtract from, you take those two numbers and subtract them, that's how you get 22?
Which one? I put 2.055 minus 0.2325.
Okay.
And I had 2.055 plus 0.2325. So that gives you a standard deviation on each side.
Okay, gotcha. All right. And then for 23, didn't we kind of already answer those?
23 is a different question. Or it's just asking for the normal standard deviation.
Okay.
And I don't remember where the rule is, but if you look in those summaries that are above the questions,
Uh-huh.
it says standard normal distribution is the mean always equals 0 and the standard deviation is 1.
Oh. Oh, I see that. Yeah.
Yeah.
Well, okay then. So the mean is 0 and standard deviation is 1.
Yeah. Yeah, so it's just, I don't know, something about it being normal, I guess.
Oh, okay. Oh, and I emailed our teacher,
Mm-hmm.
and he said, I asked him, just because I noticed on the, like, I asked him if we were allowed to use just one sheet of paper, like one side of notes, or the internet, or just like one of the other. And he said we could actually use anything. He said it's an open book test, so we could use our notes, we could use the internet. So, I'm just gonna write all the things in the summaries onto a piece of paper, just so I have them all right there.
Yeah,
And
I
then
think
if
that's what most of it is.
yeah, so that's kind of just what I'm gonna do. Just
Are you talking about the test we're getting ready to take tonight?
no, for tomorrow, for the
I mean
first
tomorrow. Yeah.
for the first unit exam that we have.
Mm-hmm.
We can use any like one sheet of notes, like just one side of notes, or we can use the internet. Well, and we can use the internet. So yeah.
So, okay, so it's not free open book. It's one page allowed or the internet, or what?
So I emailed him and I asked him if it was one or the other, and he said we could actually do both.
Okay.
So
There's no restrictions, right?
what?
There's no restrictions then is what you're saying.
I guess that's kind of what I understood, but on the instructions it said we could have one sheet, like one side of a piece of paper of notes
Okay.
or the internet, and so I'm just going to use one side of a piece of paper to write notes, and if I have any questions, I'll just go to the internet. And he said we could do that. So.
Okay.
Yeah.
All right. Thank you for asking.
You're welcome.
All right. How are we doing? Are we getting tired? Should we get to 24 now?
Yeah. Yeah, we're ready for 24. Okay.
It's almost 10 there for you.
Yeah.
Yeah. So it said number 24, the admissions committees for most matters of business administration programs require the GMAT as part of the application for students. It has been shown that the scores of GMAT are normally distributed with a mean of 542.3 and standard deviation of 120.5 for the minimum GMAT score required for admission to the MATH program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Use this information to answer questions 23, 24, 32. What is the probability that a randomly selected student will score above 542.3?
I put 50% just because, or 0.5, because it's the mean. So it's kind of, if the mean, when you have a normally distributed, the mean is also the middle. So it'd be.
Yeah, that makes sense. That makes sense.
I plugged it into a formula and then I put it in the applet. That's how I did it, but I guess that's wrong.
Well, I think if you did it that way, you would get, you'd get 0 for your z-score. Because you'd be doing the 542.3 minus the mean, which is 542.3.
Yeah, that's what I ran into. I'm like, am I doing this right? Yeah.
Yeah, I started to do it that way, and then I was like, wait. So
and then
I
switched how I did it, and I thought, okay, maybe this is the right way. So, okay.
Yeah, so because it's the mean. Little girl. Sorry.
Uh-oh, the cat's invading. Okay.
Well, she was going into my room, and she's not allowed to, and she knows that. So. But I have a fuzzy blankie, so she sheds like crazy. So we don't let her in the house during the day. So she's like, I want to sleep.
So for number 24, you did the equation, just the, where did it go? Just the little, what do you call that? It's like the little O with the line above it.
Yeah. Sigma.
Sigma, thank you. Divided by the square root of n, right?
I didn't use that one. I used the more simple one, the x minus the u with the extra tail over 6. I forgot what the Latin name of that one is.
Okay.
But I got about 0.66. So I don't know if that's right.
Well, I think the first time you did it with the 0, when you got 0 for the z, if you put in 0, it only gives you one line, but that's because it's the mean. The score is the mean. And if you highlight above it, it gives you your area, so the probability.
And then it come up as 50%?
Yeah, it comes out as 0.5.
Okay.
Because I think normally that is what you would do.
Okay. So how do you solve number 25 now that it's not, is it 60%? Is it 600?
Um,
Not the mean.
on 25 you can do it like normal, so it's 600
Right.
minus
542.
542.3.
That's what I did.
And then divide it by 120.54.
4. I got 0.478.
Yeah.
Yep. And then we'd have to put that into the applet.
Right.
Yeah.
So when it's saying below, so you're going to do the middle and to the left, right?
Yeah.
Okay. Okay. So 0.6837 or what is it?
Yeah,
0.68?
I got 6840, but I think
Right.
I think I put an extra number possibly.
Or you just rounded it off because it's 6837. So I could see how you got that.
Yeah, because I think if I put in. Oops. Yeah. Okay.
Okay. So for that,
So 26, it's just the other side of the
Right.
z-score.
At 0.32.
Yeah.
Yeah.
You could even, instead of putting it in there, you know that everything equals 1 that's under there. You could
Right.
put 1 minus the area of the other one.
Oh, that's right. So you could potentially put 1 minus 0.684.
Mm-hmm.
Okay.
Just a, I don't know, reminder, I guess.
No, I need those reminders. I don't have a strong mathematical mind like you, so I'm grateful to have you on our team.
Well, thank you. I'm afraid one of these days I'm going to be just really off and not know what I'm doing, and I'm going to lead you all astray.
Well,
That's
so
okay.
far, I'm not trying to lead or follow blindly. I'm also trying
Yeah,
to
you're
be
trying to do
invested
it, so
here.
it's okay.
Yeah.
well, so then how do we find, like, for number 27?
Yeah,
It
I was.
said to find the 10th percentile.
This is me scratching my head because I don't understand it.
Your percentile is your probability.
Okay, so we just put that at the top of the thing then. So just
That's what I did, and it didn't seem like that was, like, it didn't jive to me. I was like, really? That doesn't make sense. But okay, let's go for that.
0.1 in.
Uh-huh. And you
And it
got
gave me
0,
the z-score.
and you got 0.78.
I got negative 1.282.
So what part is highlighted for you?
The one on the left. Let me read the question, make sure maybe. Yeah, so you want to, when it just says to the whatever, you want to do to the left because when it's to the left, it's at or below that.
Okay. So now I see that. Okay. So negative 1.282, you said? That's what I got, yeah.
Yeah. And then you plug that in to find x.
Oh, I see. Okay. Let me go for that.
Yeah. You always have to check where you're highlighted because it can throw you off really easily.
Does it matter if you plug it in negative or positive?
Yeah, because the two different z-scores.
Okay. So negative, right?
Mm-hmm. Yeah, because like if you just put 0.1 and you're already highlighted on the left, it just naturally does it for you. So that
Right.
it's to the left of the negative. So that's how I knew it was the negative one.
So then what did you get for 27? Or sorry, not 27. Wait, yes, 27. So because right now we have to find the z-score, which I got was negative 1.282. But then we just plug in the what should we call it? Z. Well, so then we just try to find at in that equation, correct?
Yeah. So you're just multiplying by the standard deviation and adding the mean.
Okay, so then what did you get for it?
I got 387.76772.
Maybe I just calculated it wrong. So the equation now would be x equals z plus the little u times the standard deviation.
You want to multiply by the standard deviation first. Did you do that? Or did you just do it all at once?
Yeah. So the standard deviation is 120.54, right?
Mm-hmm.
And multiply it to get rid of the fraction, and then put it over on the other side. That's what I did too.
Yeah. So I multiply that over, and then I add 542.3 plus negative 1.282.
Yeah. So or 142.3. You add 542.3. Is that what you had?
No. So.
Okay. So I got negative 1.282, and then I multiplied it by 120.54.
That's what I did.
I got negative 154.53.
Right.
And then when I added 542.3, I got 387.76772.
So then you got 387.768 or so.
Yeah.
Okay, yeah, that's fine.
So the G score, which would be very low, and you wouldn't pass, and you wouldn't get into business school if you were under 2%, is 387.76.
Yeah.
So that means
But it seems like only 10% of people get that.
So then, so then the 90th percentile.
You go back to the applet. Okay.
Yeah, so you're going to do that same thing where it's already highlighted on the left and put 0.9. And then it should give you your positive z-score. And you do the same thing.
So did you get 0.901? Wait, no, just joking. Wait. you get 0.0999?
For the z-score?
Oh no, sorry. Oh, I'm sorry. I don't know what I'm sorry. I looked at something wrong. Sorry.
Okay.
So for the area, I put 0.9 in, and then for the z-score, did you get 0.1282?
1.282. Yeah.
Yep, that's what I got. Okay, and then we just do the exact same thing.
Yep.
Okay, so that would be
So it's the same z-score, but we're using the positive.
Yep.
correct.
Okay.
So then, did you get 696.832?
Yep.
That's what I got.
Yeah. 29 and 30 are pretty much the same as well.
Oh, okay.
Just a different z-score.
So how do you find the first quartile?
Your first
Okay, yeah. So I just, the mean is 542.3, right?
Yeah.
And
Well-
then just move it over. Wait, no, just joking.
Your quartiles are just like your percentages. So your first quartile is the same as the 25th percentile.
Oh, yeah, I got you. Yeah, that makes sense.
So then you got 75 would be the third, right?
Yep. You can just put that in the area. So 0.25 and then 0.75 for the other one.
I'm sorry to jump back, but what did you get for 28 again?
696.832.
Okay, I did not get that. All right. Figure out what I did wrong.
For a second, I thought I heard a tune I recognized. There was someone not whistling, and I'm just hearing things.
No, I heard someone whistling. Who was whistling?
Oh, sorry, that was me. I whistle a lot.
That's okay.
Um,
I just thought I recognized it for a second. It made me laugh.
Sound like a commercial
Oh,
to me.
I thought it sounded like a theme song for a second. It's probably none of those things, huh?
Care to share?
it was a song called Geronimo. I don't know if you guys have heard it, but
Probably not. I don't think so.
All right, now I got that number. All right, catching up with you guys. So Victoria, when you put in 0.25 in the area, does the z-score change?
Yeah.
It didn't change for me. I'm wondering what I'm doing wrong. Do I need to highlight a different area? This the middle? Or should it be the left?
Just to the left like it was before.
Hmm.
What did you get?
Well, I put in 0.25. Should I be putting in something else?
No, that's right. Did your z-score didn't change to 0.674?
No.
Weird. Well, you can use mine if your applet's not working.
Okay. Well, for the sake of time, before we get too tired and it impairs our ability to take a test.
Yeah. Well, I think the test was just exactly this. So we're just like putting in the answers in.
Okay. Well, it's important to get this right then. So, yeah, I don't know why my applet, maybe I need to close it out and go back into it or something like that. What was the number you got for the first quartile?
Negative 0.674.
Okay. Okay, now it changed.
Oh.
Hey, Victoria.
Mm-hmm.
How would you do number 31?
31?
Yeah. What are the standard deviation of the distribution of sample means?
So this is like what we were doing like recently. So our mean stays the same, but we use that
Sample. The
standard
square root of.
deviation, yeah, divided by the square root of the sample.
Right.
Okay. So the mean is just normal. It's just
Just the same.
542.3.
Yep.
Okay, and then the standard deviation, would I just do 120.54 divided by the square root of 15?
Yep.
Okay. Okay. So did you get, for that standard deviation, 31.123?
Yep.
Okay, cool. Alrighty. Well, then I don't. And then for number 32, did you get the probability of 0.0319?
Yep. That's what I got.
Okay.
I'm sorry. What did you put as x in the formula for 31? 500? No.
In 31,
Mm-hmm.
31, you just have to say what the mean and standard deviation are.
Oh.
So you're
Okay.
just saying the mean's going to be the same, but your standard deviation is going to change because of the sample. So you'll do the 120.54 divided by the square root of
Oh,
15.
okay. The mean, after that, then the mean is 542.3, and then you do the formula to get the standard deviation. Okay, change to the sample size. Okay. That still doesn't answer my question. I'm sorry.
Oh, okay.
So I'm confused. I'm just getting tired, probably. The standard deviation, the distribution sample mean scores for all sets. So we're using that formula like Walker said, z equals x minus u over sigma square root of n, right? Is that what we're using?
Divided by the square root.
Divided by the square root of n. Okay, so what is the x in that?
For 31, you don't have to have an x. You're just saying this is the mean, and your standard deviation is just what's beneath the square root. So or the bottom part of the dividing.
Oh, okay, so you're just dividing. Oh, okay. So we're doing.
So your standard deviation from your population or your other sample
Mhm.
divided by the square root of the number of the sample is your new standard deviation. Is your standard deviation of the distribution of sample means.
So what does that formula look like? Is it just then u over square root of n?
It's just the theta
The theta.
over the square root of n.
Okay. Okay, thank you. So it changes significantly, doesn't it?
For
31, the standard deviation goes 31.12. Is that what you got?
yeah.
Okay.
Yeah, so yeah, it does change a lot. I guess it's just the sample size. I think it's because you know how you have to have 30 for a normal
Right.
sample size, so I think it's probably because it's below 30.
Right, exactly. Are we ready, or are we still calculating?
Yep, I'm ready whenever you guys are.
Okay, I just have one more question. Now, this has been a long, dragged-out process, and we're halfway there. The Z-score that you got for 32, what did everyone get? Because mine is too big. It's above 1, so.
Mine was 1.8539.
That's what mine was, yeah.
Okay. So to set it up, you did 600 minus 542.3 over, that was over 31.12, square root of 15. Is that how you set it up? Or no?
You would just do 31.12. That's your new standard deviation for that one.
I don't need to do the square root of 15 because we already did that in 31, right?
Yeah.
That's where I went wrong. I'm sorry if I'm holding everyone up.
It's all right.
Lena, are you awake over there?
Yeah. Sorry.
Yeah. Okay.
Well, I think at least the test, it sounded like the test is the exact same thing.
Okay.
So,
Yeah, I actually pulled the test up and it's pretty much exactly the same.
okay.
So we should be able to go through pretty quick.
We should cruise it?
Mm-hmm.
Okay. Alrighty, I'm going to pull it up then.
Let's see.
Alright, are we ready to do the quiz?
Yeah, I just pulled it up, so I'm ready.
Okay. Right, so I'm ready whenever you guys are.
Okay.
Alright, so number 3. Which of the following variables is or are categorical? Didn't we say just a randomly selected brand of toothpaste?
Yes.
Yes, but, oh wait, yeah. Sorry, I read one of the things wrong.
Okay.
Yeah, for a second I just thought it said animals in general.
Oh, gotcha.
Yeah, nope, we're good.
And then number 4, isn't it just 100 is a parameter and 112 is a statistic?
Yep.
Yep.
And number 5, didn't we say that was a stratified sample?
I feel like I gotta read through it again. Yeah, I think so.
And number 6, their sample.
Cluster, right?
Yep. And number 7, I think we put was just a simple random sample.
Because it's like drawing out of a hat kind of thing.
Yeah.
Yeah.
And then number 8 is stratified. Right?
Yeah.
Okay.
Yeah.
And then number 9, didn't we say it was 4.77? It says around the 3 decimals, but I only have 2. So does anybody have a third decimal place?
Mine has 4.7711.
Yeah, that's what I have too.
Okay, so just to 3 decimal places, so 4.771.
Yeah.
Okay. And then number 10 is calculate the standard deviation. Was 1.91. What was the third decimal place?
I have 2 because it was 199 was the last after that.
Okay. So you have
Good.
1.9199.
I got 1.91199.
What did I?
Okay, so 1.912.
Yeah.
Okay. And then number 11, if you created the histogram. And then number 12, wasn't that one the negative 0.165?
Let me get there.
Yeah.
Yeah.
And number 12 was 0.681.
Wait,
Uh,
is it 12? 12 is the negative?
That's what I have, yeah.
Okay. Just making sure.
so negative. I'm still at 12.
So 12 was the negative,
Just the number that goes in there. Yeah.
yeah,
Negative
negative
0.
0.165.
Yeah.
And then
Yeah.
number 14, you say that was the variant. Oh, sorry, 13.
Yeah. I'm on 13.
Sorry.
It says the number that goes in B. Okay. So that's 0.684. Is that what you
I
got?
have 681, but maybe I have it wrong.
Yeah. Well,
I have 681.
681. Okay.
Because I got 6806. 681.
And that's a negative, right? Or positive?
That one's positive.
That one's positive. Yeah, it's bigger.
Yeah, because
Okay.
those ones are squared.
That's right. Get rid of them.
Number 14, don't we have the variance?
Yes.
Yeah.
That's what I put.
1.239.
Yeah.
1.9. Yep.
And then 16 is false.
Yep.
And number 17, which location? That was the extra dural.
Right. Unless they change the numbers. Let's look at it and make sure it's still the same. Okay.
Yeah.
And then if you can define standard deviation in your own words.
True.
And then number 19, the third quartile is 8.
Yep.
Are we putting the 0.00 on it for effect, or are we just going to leave it?
No, it doesn't say to go to decimal places, so I think we're okay.
Okay.
And then number 20 is 50%. And you don't have to put the percent signs.
Percentage of the data lies between 40 and 20. I'm sorry, 50%, right?
Yeah.
Yeah. Okay.
Okay, then 21. Did you get let's see, the mean was 2.055, right?
Yeah.
And then 22, the standard deviation was 0.233.
0.233, yes.
And then 22 is 2. So for number 23, didn't we have 2.28 and 1.823? Oh, it's right there. I see it. There we go.
It's the second one, right? 2.055 and 2.520?
No, this is the
68%. Okay.
this one standard deviation away from the mean. So you're adding the mean, or you're adding your standard deviation to the mean,
Oh,
and you're
so
subtracting it from the mean.
1.822. That one?
Yeah, it's number 22 on our homework.
Right.
And then for 24, did you get 0?
Yeah.
And then number 25, 1?
Yep.
Okay.
Yep.
And then 26 is probably around 16. Wasn't that just 0.5?
Yeah.
Trying to get them both up here. Let's see.
And that's the nearest tenth anyway.
Mm-hmm. And then 27, did you get 0.684? That's what you got?
Yeah.
Where are we at? Okay, I'm sorry.
27.
What was 20? What was 26? On the random selection number above.
0.5.
Yeah, 7.5. Yeah, 27, below 600, 0.32. Okay.
Where? For which one?
You're on 27, right?
Yeah, I have 0.684 for
Oh.
27.
I'm looking at the wrong number. Yeah, okay. Thank you.
I think 28 is the one you were looking at.
What did you get for 28, Victoria?
0.316.
That's what I got.
0.316?
Mhm.
That was 26 on our homework. I'm looking at mine beside it.
And number 29, did you get, it says to round to the whole number, so 388.
Yep.
Yeah.
And then 30 was 697.
Right.
And first quartile was 624.
First quartile?
Right, isn't that what it said?
I got 400.
Oh, sorry, I smoothed. I'm
Oh.
sorry, yeah.
Okay.
So, did you get 461?
Yeah.
Okay, there we go. Yeah, sorry, I just switched those on the paper. I even drew an arrow, but I forgot to look at it. And then for 32, did you get 624?
Yeah.
Oh, okay, cool. And then 30.
Third crown. 624, you said?
Yes.
Yeah.
And then 33, I got the mean is 542.
0.3, right?
Yeah.
That's what I
5.2.3.
got. Yeah. And standard deviation. Did you get 31?
31, 1, 2, 3.
And then 35, I got 0.032.
Oh, yeah. Let me round it. Yeah.
What did you get for 32? You got 582.57. Or what is that?
And 32, I got 624.
Okay. Okay.
And then did you get 33?
542.3.
Yep, that's what I got. Okay. Then did you get 34 and 35?
34, I got 31.123. And then 35, 624.
No. Number 32 was 624, but number 35, I got 0.032. Is that what you guys got?
That's what I have.
Okay.
Say it again, I'm sorry. 0.32.
0.032.
32.
Yes. So there's two zeros. 0.032.
Okay.
Okay. Are we ready to turn it in then?
Yep.
Yeah.
Hopefully I steered you all on the right path. Some of those.
Hey. Oh. Um, looks like we missed 2, but that's okay.
Yeah. I just the 14 and 15 is what I got wrong.
That's
Yeah.
right.
Me too.
Okay. So, okay. Well, alrighty then.
So it must have been. So maybe we had to add the numbers up and then square them.
Yeah, maybe.
I have to look into that. Okay.
Yeah, we'll have to check that. But otherwise, we got an A. Yay.
Yeah, good job.
And it's not midnight, so that's okay. Not that we've gone that late before, but just saying.
Alrighty. Well, perfect. Well, I will see you guys on Thursday. Good luck on the test tomorrow.
Okay.
Thank you for the help.
Yeah, no problem.
High
Well,
five.
just-
It's time for a victory bowl of cereal.
Yeah.